All right, so Harmony Core hands-on workshop. What we are going to do and what we hope to achieve this morning and into the afternoon, I honestly don't know how long this will run, but my intention is that by the time we get into the morning, you get the process, you'll understand what we're doing, you will have a good understanding of how to finish this thing off yourself anyway. And as I mentioned last week, we're going to publish the instructions for this in the wiki at some point. Probably it'll take me a few days to get it into shape and get it out there. So the objectives really are to help you understand how a Harmony Core web service environment fits together and how it works. Again, please bear in mind that, as Jeff said the other day, there's no requirement for you to do it this way. If you want to pick up the EF provider and implement your own web services, be it OData or not, some other way, and expose things a different way, you're absolutely at liberty to do so, and it's absolutely possible to do so. What we think we've built with the code-generated environment is a really easy and quick to get up and running, great starting point. It's never going to represent, well, it may in some cases represent 100% of what you want, but it's unlikely to represent 100% of what you need. It's likely to be, like I say, a starting point that you then customize and tailor and add operations to and add custom code to, and so on. So what we really need you to do is understand what the various capabilities are, what the various pieces and components are, and how they all fit together, how they relate together. So what we're going to do this morning is build a Harmony Core web service or a set of web services for a sample data set, which is ultimately based on the old report writer data. We just picked up that data. I have reformatted it somewhat. There were some things that had been done in that original data set that just didn't make a lot of sense. So we've sorted a few things out and improved a few things. We're not dealing with thousands and thousands of records. It's still the original data as it was. So there's not a huge amount of data in there, but hopefully it's enough to help you understand how this thing works. So my goal is simply to have you understand enough about this environment so that you have a real good chance of being able to know exactly how to get started building this stuff in your own environments. And I've already mentioned a couple of times there will be an awful lot of code generation and virtually no, in fact I'm not even sure if there's any actual code that we write. It's literally plugging stuff in, turning stuff on, adding generated modules to the solution, building it, looking at the code, seeing what was generated, and understanding what it does. The requirements, and hopefully you've all got these at this point in time, we do require Visual Studio 2017, 15.8 or later. We need the .NET Core SDK. We need the latest and greatest version of Synergy 10.3.3F, because that's where we formally support .NET Core development. We need the latest, this is the latest version of CodeGen as of today. That's likely to continue as we develop. We've added, I don't know how many, but I've done probably 6 or 7 CodeGen releases in the last 3 months, well, maybe 4 or 5 months, as we found new things that we needed to do. For example, we're not utilizing this in the Harmony Core product yet, or environment yet, but we are able to not only ingest metadata from a repository these days, but we're also ingesting data from xfServerPlus method catalogs. One of the to-dos for Harmony is to be able to read a method catalog and expose a set of RESTful web services that reflect what that xfServerPlus environment exposed and call those methods. So there's been a lot of changes to CodeGen in the last few months, and that trend will probably continue as we add more and more stuff into Harmony Core. So best thing if you're using this environment is just, if you're not subscribed to the release information for CodeGen, then go ahead and do that on GitHub and make sure you get those notifications and just keep up to date. Optionally, there's a tool called Postman that has been mentioned a few times, and I think we've demoed a couple of things in it. We'll be using Postman on and off to test our operations that we implement. As I mentioned the other day, in the early stages when we're just building read-only services and queryable services and stuff like that, you can pretty much test everything just in a browser. But as soon as you need to do anything beyond a GET request, then you need some other way of doing that. You've either got to write some code, write some unit tests, or use something like Postman, or there are a few others that do a similar thing as well. And you will require internet access just initially, because again, this is .NET Core, everything is a new Get package. You know, when you ran that batch file the other day, what that did, and just so that you know in case you want to undo it, although there's really not a lot of reason to unless this is a machine that you only ever intend to do development here on, but what it actually did was it copied my NuGet cache, which was cleaned out recently. So my NuGet cache at this point in time is pretty much what's needed for Harmony Core development. And it resides in your user profile. So if you want to get rid of it later, if you look in the users folder under your username, you will find there is a folder called .NuGet, and in there is a folder called packages, and this is the NuGet package cache. So it's stuff that I've added references to in projects in order to support Harmony Core, and these packages have been downloaded and cached on my system, so they're still there for use. So it's that .NuGet packages in your user profile if you want to get rid of it. Okay, so the workshop approach is going to be fairly simple. You're going to follow along. At each stage, I'm going to give a brief introduction that might be anywhere between 1 and maybe 3 or 4 slides just to explain what it is we're about to do. I will demonstrate the steps to implement whatever that next part is on my system. You can do exactly the same on your system and follow along, and hopefully by the end of the day we'll all have a fully implemented and fully working system. Everything that I do on my system, assuming you've got the prerequisites, you should be able to do on yours just fine, and hopefully we'll all leave with a working solution. With Harmony Core development, the project templates come from NuGet as well, and I've actually got a version of the project templates that have got some additional files in to support this workshop specifically, and that stuff is live on NuGet as well. So you will be able to go through this whole procedure, and I will leave that there. Well, I guess we'll probably just leave it out there. Okay, so preparing your environment, I just want to make sure we check a couple of things. So if everybody could please open up a Windows command prompt. And the first thing we're going to do is verify that everybody's got the .NET Framework SDK successfully installed. So if you open the command prompt and type in a command .NET, D-O-T-N-E-T, --, version, and hopefully you should all see it reporting 2.1. something. I'm not sure if I'm latest and greatest, but 2.1.3, 3 something, 2 something, 4 something, any of those should be just fine. Okay. So that's a good way of verifying that we've got access to the .NET command line interface and the SDK is therefore installed. The next thing we need to do is make sure that we're going to be doing everything with HTTPS, with TLS enabled on our services. So the next thing we need to do is make sure that we've all got a developer certificate, a self-signed certificate, and .NET Core now provides a real nice and easy way of doing that. So if you type in the command .NET, dev-certs, C-E-R-T-S, space HTTPS, that will create, if you don't already have one, a .NET developer certificate. If you do, it will report that the valid certificate is already present. Okay? And there's one final step, which is to install that certificate in your certificate cache. If you're not familiar with it, Windows, you don't need to do this yourself, I'll show you. Windows has a Manage Computer Certificates utility, which is just a little console that basically has certificates. So for example, trusted root certification authorities are all listed here. And if we look under personal certificates, you'll see that we've got these certificates that have been installed. This is the IIS developer certificate. That's what we're about to install on your system. Okay? So the next command is the same as the previous one, .NET, devcerts, HTTPS, --, trust. So if you all type that in, now if this is the first time that's happened, on my system it's just going to say it's already there. What you guys should see is a dialog popping up like this saying, you realize you're about to install a trusted certificate? So you should see a dialog like that, hopefully. And there we go. The third thing, let's just verify that everybody has the right version of Visual Studio installed. So if you can all start up Visual Studio, if you don't have it on your taskbar or in your start menu, if you just go to the search box in Windows 10 and type in Viz, make sure you don't pick the installer, you want to pick Visual Studio 2017. And let's go in there, and once you're in there, let's just go into Help About Microsoft Visual Studio. And hopefully we've all got a version that's 15.8 point something. You can go ahead and close out Visual Studio, we'll start it a different way. All right, so it seems like we've got most of the requirements in place. Actually, 1 or 2 more things, aren't there? Let's check. Let's check what version of CodeGen everybody's got available. So for that, if you type in the command CodeGen, if you've just installed CodeGen, by the way, which I know at least one person in the room has, you might need to log out and log in to Windows to get the CodeGen in the path. You may or may not need to. So if you type in CodeGen minus version, it should report CodeGen 5.3.6, built 23rd of September. Okay? All right, if it doesn't, if you get a not found, just log out of Windows and log back in again, and it should be there then. Sometimes Windows doesn't update the path when the installer runs, so if it's the first time it's ever been installed, that can be an issue sometimes. Totally optional, but I like to, as you saw in some of my demos earlier in the week, when I go off to a web service endpoint and actually exercise that endpoint, so if I go off to our Harmony Core on my local IIS, and ask it for a single customer, you can see it's nicely formatted with some colors and things like that. That doesn't happen by default. By default, Chrome just gives you black and white, not formatted. It's really tough to read. So this is happening because of a Chrome extension. You don't have to use Chrome. If you're not, that's fine. But if you are, there's a really nice extension called the JSON Viewer that's out in the Chrome store. And all it does is give you that kind of nice formatting. There are a few options that you can configure and how it, what it does and what its color schemes are and things like that. So absolutely not a requirement, but I really find it very, very nice to work with. So, assuming we've all got those prerequisites, the next thing we're going to do is install the Harmony Core project templates. Okay, they're going to come from a NuGet package. You can see here the command that allows you to deal with projects and things, if I go back to my command prompt, is if we say .NET new, that's how you create a new project from the command line. And if I do so without any additional parameters, it will give me a report of what project templates are installed. You won't have these two Synergy ones right now unless you've figured out how to do that on your own, and if you have, great. But you'll see we've got a project template called HC Workshop and one called Harmony Core. So the Harmony Core is the mainstream, ongoing way of creating a Harmony Core environment. What it will do is it will create you a Visual Studio solution that contains 2 or 3 projects, no, at least 3. There's a repository project, there's a services class library where your services go, and there's a very simple self-hosting environment that's created. The HC Workshop template is basically a copy of the Harmony Core template, but it also contains a sample repository, it contains sample data, and a few other things. The code generation batch file has been slightly tweaked for the workshop, but it's basically a version of the base project, but with additional files for data and testing. To get those project templates, you're going to use a .NET new command, and you're going to say .NET new, and everybody can do this, so .NET new space -i, and then harmony.core.project templates. And what that will do is .NET new -i goes out to NuGet.org, locates that package, downloads it, and installs it onto your system. Okay? I'm not going to bother running it because I've already got the project templates installed. Oh, sorry, I haven't got a space in front of there. There we go. So that might take a few seconds. Okay, as it downloads, is that working for people? And then the second command, same thing, but harmony.core.workshop templates 2018. They're at the top in yellow here. Okay, so, all right, so now we've all got project templates. Now we can create Harmony Core projects. Awesome. Okay, so we've all got our project templates. So what we should now be able to do is create an environment. A basic project. So what I would like you to do is, in your Windows Explorer, go somewhere that it's okay to create a subdirectory. So maybe you go to your Documents directory, or wherever it is. We're going to create a subfolder that's got files in. So just make sure that you're somewhere where you want to create this project. And what we're going to do is use another .NET new command. Let me type it in first, and then I'll put the big yellow version up on the screen. So we're going to say .NET new, we're going to say HC Workshop. Now, if I just use that command, it will work. It will create a new solution called HC Project, but it's going to create it in my current directory, which is not where I want it. So I'm going to say sorry, that's the name of the template. I'll use a default name. So I want to do 2 things. I want to name it, so I'm going to use -n, and it wants us to use Harmony Core Workshop. And I'm going to tell it which subdirectory to create it in. So -o, same thing, Harmony Core Workshop. So by doing that, we're not going to pollute the folder that we're in right now. We're going to create a brand new subfolder. So I'm going to run mine so that you can see what happens, and then I'll put the bigger version back up on the screen. So you can see it's creating directories. You see right now it's restoring a bunch of NuGet packages. So they're coming hopefully out of that package cache and not downloading a bunch of stuff. Okay? And it's finished. So at that point, I should be able to CD into that Harmony Core Workshop folder. And then let me display that. So let's make sure everybody gets caught up with that. So while yours is finishing off, let's just look at what happened. So let me go into Windows Explorer, and we'll go into that folder. So here's the workshop. Okay, so here's the folder that was just created, Harmony Core Workshop. And within it, you'll see, if you're familiar with Visual Studio in the past, you'll see what just looks like a regular old Visual Studio solution. So we have a solution file, harmonycoreworkshop.sln. Here's the two code generation files that we talked about earlier in the week. So we have a batch file called regen.that. We're going to be spending a lot of time looking at that and what it is and what it does. We also have this user-defined tokens file that I mentioned yesterday that is our way of customizing certain values in the environment. Again, I don't think we're going to do too much with that, but we'll take a look at it once we get into Visual Studio. We have several projects here. So in the sample environment, let's just go through them. Actually, I think I've got a slide about this, so let's go back to the slides. This environment that was just created, what you should be able to do, one of the projects is called services.host. So you should be able to CD into the services.host folder, which is the self-hosting program. Okay? And we should be able to build and run this example. The sample should run out of the box. So we should be able to say .NET build, and it should build the project and all of its dependencies, which are all the other projects. Okay, build succeeded. And we should also be able to run the service. So we should be able to say .NET run. So we've done three things so far. We've created a project, we've built it, and we've told it to run. And hopefully, what you should see is something like we're seeing here, application started, press Control-C to shut down. So this, the Harmony Core.host project is a console application, and it has some self-hosting code to start and host an HTTP service with a web service. We're going to be looking at all the code later, so there's not going to be any smoke and mirrors here. I just wanted to show you that the project templates create something that builds and runs. And it says that it's listening on HTTP localhost 8085 and HTTPS localhost 8086. In theory, you should be able to go to either one of those URLs, and if you go to the HTTP one, it should just redirect you back to the HTTPS one. But if I grab that URL and copy it, and then open up a browser and paste it into a browser, and you should be able to do the same thing if your service is running, then you should see something like that. Okay? This is the baked-in little homepage that comes with the service, and all it does is allow you to drill into the list of exposed entities. Well, the sample service has an entity called books and an entity called presses. You should also be able to view the OData metadata for the service that describes the entities and the endpoints and so on. And you should be able to query the entities. So these three links here are examples of querying. So a simple query for all books should return, there's only a couple of books in the database. So you should at this point have a working OData service that we can start now to modify. Okay? And if we go back to our console app, you can see that as we've been making requests, there's debugging code in there that just logs those requests out to the console so that you can see what's going on. Okay, and we'll hit Control-C and close the thing down. So we've downloaded and installed the project templates. That's a one-time thing. Now you've got them. We have used a .NET new command to create a new workspace containing several projects. We have used a .NET build and .NET run. Actually, you don't have to go through both of those steps. Just like with MS Build in Visual Studio, if you just type .NET run, it will build the thing if it needs to, and then run it. We're not going to hang around at the command line much longer. We're about to jump into Visual Studio any moment now. but it's nice to sort of understand that this is what's kind of happening, and that's how you get up and running with the project in the first place. And even though we can build and run from the command line, typically we're not going to do that an awful lot. Okay, so bear with me a second. What I want to do, and this is simply to allow me to be able to highlight changes to you guys as we go through. So what I'm going to do is, and you don't need to do this, I'm going to create a Git repository, and I am going to add everything to that repository. Oops. And I'm going to commit those changes so that when anything changes in our environment, I'll be able to use diff tools to show you exactly what changed and what we generated and so on. So whenever you see one of those reminder slides, that's just a reminder for me to go ahead and check stuff in so that I can show you differences at every stage along the way. Okay, so next we're going to get into the main meat of this and look at what we just created. So we're going to open Visual Studio. So to open the project in Visual Studio, what you need to do is get back up into the solution directory. So you want to be in the Harmony Core workshop folder, which probably go up one level if you were down in the host project. And then we're just going to open the solution. So if you type Harmony Core workshop.sln, or if you type HAR and tab a couple of times, it should find it, and just run the solution file, and that will open the solution in Visual Studio. And it takes a little while to open and initialize everything, so just be patient with it. Then once you've got the solution open, what I'd recommend you do is on the Solution Explorer toolbar up here, this little button here is Collapse All. So it just collapses down all the projects so that you can see them. Okay, so you should find that what we've got in our new environment is several projects. We'll go top to bottom. So we've got a project called Identity Server. This is an instance of an open source OAuth 2 and OpenID Connect server product called Identity Server 4. We're going to use this later in the day, right at the end. We're going to use this to turn on authentication. I've already got it pre-configured. It's got a little SQLite database. It's got a couple of user accounts defined. They've got some roles defined. And we will be configuring and enabling our web service to talk to that identity server and do some authentication later in the day. There are commercial versions of Identity Server available. It's more likely in the world that we live in that we'd probably use Active Directory Federation Services or Azure AD or something like that. This basically fulfills the same role. It's an OAuth 2 server. We'll look at that one later. We've also got a repository project. And you'll notice that one is bolded right now because it's the first Synergy project, I guess. In there, we've got a repository schema. We'll take a look at that in a moment and explore what's in there. But that's a Synergy.net repository project that we reference from the other projects to get access to the repository. Services is where we're going to be doing most of our work. That is a .NET Core class library. And that is where we're going to be implementing our RESTful web services and our models and our controllers and all of that kind of stuff. Services.host is the command line self-hosting program that references the services project, and that's the program we can run to start the service and host it. Services.test is also a console application, and right at the end of the workshop we're going to generate some unit tests into that project and show you how the unit testing environment works. So most of the time we're going to be concerned right now with the services project, and we're going to do a little bit of work in the services.host project to configure self-hosting as we go. Okay, so that's what we started off with. So let's take a look at the sample environment and what we've got. Let's take a look at the service that came along with the environment. So if we look in the services project, you'll find that we've got various folders there. You don't have to follow this hierarchy, but it's kind of a strong recommendation that you organize your web service projects in this kind of way. So we have a project called Controllers. That's where we're going to be putting our web service endpoint controller code. We have a folder called Models. That's where our data models are going to go. We're going to be getting very familiar with all this stuff as we go through the day. Custom functionality, okay, is where we're going to be, guess what, coding some custom functionality in our web service later in the day. We've also got a www root folder. This is where static content, this thing is a web server essentially, and we can serve static content. Our little homepage that we see when we run up the service, for example, is an example of just serving up a static HTML page. So the www root folder is the root directory of the web server. So if we want to serve out HTML files or JavaScript or CSS or images or things like that, then we can put them in or below that www root folder. You will notice that we've also already got some existing code in here. We're going to get rid of it fairly soon, but let's just take a look at what an OData service looks like in its basic form. So let's start off in the models folder and look at bookmodels.dbl. And you guys can follow along, or you can follow on the screen. Book models just has a couple of model classes. A model is a class that describes a piece of data. We often refer to them as data objects in this world as well. You'll have heard that term over many years when Richard was talking about Symfony things. The concept of a data object is it's a class that defines an object that has properties that represent the fields in a record. So that's what we're looking at here. We've got a definition of book. We've got a definition of something called press. You'll notice that the book has an address, which is an instance of location. So location is defined down here with city and street, and so on. So there's a little bit of hierarchical data going on here. So our model classes simply describe the data entities that we're dealing with. We've also got books data. So books data in the sample project just hard codes some data. Okay. So there is in entity framework, you have something called an entity data model. And the entity data model describes the entities that are available in the environment. So here we've got a getEDM model method in our books EDM builder class. And you can see that we're going to be looking at this code when we generate our real code later. But you can see we are adding entity set of books, entity set of presses, and returning an EDM model. Essentially, we're describing the schema of the data that we're dealing with at this point. So all of the entities, and embedded within each of those entities are potentially information about relationships to other entities and so on. And then we have something called a DB context. So the DB context is something that surfaces a real runtime instance of the entity data model and its underlying data. So the DB context, you will see, has a property called books, which is a DB set of book. It has a property called presses, which is a DB set of presses, and so on. So the DB context is actually what the web service code will use at runtime to access the data. Okay. Then we have, in this hard-coded example, we have something called books data source. And books data source has a method called getBooks, and you can see all that's happening here is it's declaring a collection of book, and it's hard-coding a couple of pieces of information. This is going to get called from the constructor of one of the controllers in the sample web service that we'll look at in a moment. It's not really important that you have a full understanding of this stuff. I'm just trying to give you an overview of how this stuff works. We're going to drill into much more detail in our own environment. Then finally, we have a books controller. So a controller in an ASP.NET Core Web API and OData environment, a controller contains a set of web service endpoints. Okay, so we have our books controller. This is its constructor, where it's just basically creating its instance of the DB context and loading it with the book data. And then we have two endpoints. We have an endpoint called get, which returns the collection of books. So it's using the DB context.books and exposing all of the books. And we have a method called get that returns a single result of book, so a single book, and it's doing a DB context books find query based on the key value that was passed in. So that obtains a book from the collection based on the key value and returns it through the operation. So these are the two operations on the web service that are being exposed. Okay, so that's how the sample data environment works. And we're going to be generating the same kind of things. We're going to generate an entity data model. We're going to generate a DB context class. We're going to generate model classes that represent all of our data entities. We're going to have a class for our customer record and a class for our vendor record, and those classes will have properties based on the fields in those records. You'll see the process happening as we go through. So that's how a service looks. There are a couple of other things in here that we'll look at later on, but primarily we're dealing with models, controllers, and startup code. Okay, so let's look at the startup code briefly now. In ASP.NET Web API and in OData, there is always a startup class, and the job of the startup class is to basically do two things. It's to instantiate services, so useful things like a DB context that are going to be useful in the lifetime of a controller. So services are things that can be provided to controllers through dependency injection. So a DB context is an example of something that's useful in a web service controller because it lets us get access to our underlying code. So the job of the startup class is really two things. It's to instantiate and register all of the services that we're making available to our controllers, and it's also to configure the environment. So basically, there are two primary areas that we are going to look at. We have a method called configure services. So in configure services, we are basically, here for example, we're creating an instance of our DB context, and services.add something is adding a service into the dependency injection container. So we're making services available. So we're adding the MVC service, we're adding the OData service, we're adding a DB context. So we're making all these services available within the environment. That's what configure services does. Slightly further down, there's a method called configure, and configure is basically configuring options and enabling different pieces that you want available. And again, we're going to be looking at incrementally adding code into this as we go through and build out our actual service. But in here, we can see that it is specifying a bunch of OData options, for example, and we're saying, yeah, we're going to enable select and filter and order by and count and expand, and configuring what options we do and don't want our service to support. Okay, so that's the startup class. The other part of this is if we go out and look in the self-hosting program, it's just a single console application, and this is where we're doing the self-hosting. So because we've got static files, we're serving up our home page. We're basically deriving where our www root folder is going to be. We're saying if that folder does not exist, then make it exist. And we are basically here, this one line is basically instantiating and running an instance of something called the Kestrel web server. Okay, so we are using webhost, create default builder, use content root, www root, and use web root. That tells it where its static files come from. Use startup. So that's a reference to that startup class that we just looked at that declares all the services and starts everything up and configures all the options in the environment. Here we're telling it the URLs we're going to listen on. We build the instance and run it. Okay. Yeah, you're not going to get into understanding all of this, and you don't need to at this point in time. Just right now, you just need to know that the self-host program uses this web host, create default builder, build, run, and that basically launches, it hosts a web server inside the console application process. Okay, so that's a little overview of where things are. Having showed you all that stuff about books, we're going to get rid of it. Okay, I don't want it out there polluting our environment. So what I would like you to do is in the controllers folder, select books controller and just hit the delete key and say delete. Okay. Same thing with models, books models, delete, and click the delete button. And books data in the project folder, delete, and hit the delete button. Okay. And then we shouldn't have to, but we had a little bit of an issue. Just type Control S to save. Is it Control S? Sorry, Control Shift S to ensure those project file changes have been saved. Okay, so now we've got a truly empty environment and we can start to look at building up our own stuff. Before we do that, let's just take a look in the repository. So we've got a repository project. If we're in any of these Synergy projects here, you should be able to go to the Tools menu and select Synergy DE Repository, and the repository hopefully should have been built already for us based on the schema that we provided in the sample project template. You can follow along if you wish, but you don't really need to. I'm just going to give you an overview of the hierarchy of the data that we're dealing with here. So as you can see, we have 5 data structures, 5 record layouts defined. customers, items, orders, order items, and vendors. And the sixth one that you see there, sysparams. In our environment, we have this system parameter file that is a relative file that contains next order number, next customer number, next key for each of our 5 data structures. As I explained a couple of times this week, when we do a post to create a new entity, we have a mechanism to provide the primary keys that are to be used, and that's what that 6th record layout is. Each of our record layouts, if we go into the attributes of the structure, you will see that we have the fields defined. This is a very simple data set. We have typical, customer number, name, addresses, payment terms, credit limits, that kind of thing. It's just a very, very simple customer record. You'll notice we've got a mixture of alpha and decimal and implied decimal. I don't think we've got any integer data in this environment, but if we did, it would be absolutely fine. So we have our fields defined. We also have all of the keys defined. And I just wanted to highlight a couple of things that are important again here. Whenever you're doing code generation, the repository does have the ability for you to specify the key of reference, but it's not a required field. So CodeGen doesn't rely on that to know which key is which. What CodeGen relies on is the sequence that the keys are actually defined in within the repository. So as you are defining your own repositories, I would encourage you to, in our environment, this one is defined as key of reference 1, key of reference 3, and so on. But a lot of times that information is not present. So what I would recommend is that you make sure that this is the primary key, this is key 1, this is key 2. Define them in the correct sequence. Okay? If you do have to define any foreign keys, you'll see this is a foreign key. So a foreign key is a pretend key in order that you can define a relationship to another structure when you don't have an actual key to go from in this file. So if you do have any foreign keys, make sure they're defined after the access keys. Okay. Other things to note about keys, I think Jeff mentioned the other day, do we have an example here? Yeah, this one. If you have keys that are associated with decimal fields, for example, or numeric fields, we very often ignore these 2 things over here because they're not actually required. So if it is a decimal field, it really helps the entity framework provider if we tell it this is a decimal key segment. Okay? That's not something you can do on VMS. There's no such thing on VMS. So if your back end is VMS, then you won't be able to do that. But if you're using SDMS and you've got decimal key segments, make sure you define them as decimal segments in the key definition. Okay? Again, optionally, but strongly recommended to get the real benefit of OData and querying and expanding relations and so on. If there are logical relations between your structures, then make sure you define those relations in the repository. If you're not familiar with them, these have only ever been used really for report writer in the old days, and ODBC leverages this information. But OData can heavily leverage this information. So the point is, if you've set up a repository simply to support code generation in the past, you may not have put these things in there. And it's well worth the time. All a relation is, it says, from the structure that we're currently in, from this key in the current structure, there is a relationship to this structure and out to this key in that other structure. And bear in mind that if you are in here, you do have the ability in all 3 of these fields to press F7 and get a list of keys that's available in this structure. You can get with F7 a list of structures that are available to relate to, and you can get, once you've picked a structure, F7 will give you a list of keys in that structure. So it can take some time to set up relationships. Bear in mind also, if you're doing bulk changes to a repository, you might find it easier to actually just edit the repository schema file and define those things in here as well. So if we look here, down here, here's the customer, here's the fields, there's the key definitions, and there's the relations. So relation to customer, so it's from structure, from key, to structure, to key. So it might be easier to just come in here and list them all manually. Okay, but make sure you get your relationships defined. The other critical part of this is if you do have multiple record formats in a file, then that's what the tags mechanism is for. So typically you would have, if you've got 3 record formats in the file, you would have 3 structures defined in the repository, and then in each of them you would define the tag, and the tag might be, for example, it might be something like some field contains some value or something like that, whether it's an alpha or a numeric. That's what a tag does. And the tag would obviously be different for each of those 3 record types to identify or to discriminate between those records in the file. The other part that you, didn't mean to do that. The other part that you must have in place when you're setting up the repository, so we've looked at the structure definitions, you also have to have file definitions for each of the data files, and these file definitions need to at least have 2 things in place. They need to correctly identify the file spec of the data file, and they need to have the correct structure assigned. And you do that with this assign button, so you're assigning the structure customers. We could add another one if we needed to. So that's the 2 critical pieces of information. They need to be, defined as the correct file type, relative or ISAM, have a file spec, and be assigned to a structure. So that's what we need to do in terms of repository setup. Let's just review some of the code generation environments and show you how that works. You will find that in solution items, there are 2 files. There is a user-defined tokens file. So this is the file that I mentioned the other day. And this is just providing values that we're using when we're generating code. So for example, the services namespace is the namespace that we want to use for wherever we're generating our services to. The root namespace of the project. Models namespace. The models are going to be in the services.models namespace, and so on. We've also got some descriptive stuff. The name of the data folder. I'll talk to you about how the data environment works a little bit later when we've actually generated some code. But very briefly, in the sample environment, we have a mechanism where we don't have ISAM and relative files right now. What we have is sequential unloaded versions of those files, and we have XDL files that describe those files. And the way our sample environment is set up, this is really to support unit testing, so that every time we start the server, we have a known state of the data, so that we can more successfully do unit testing. So basically what happens in our sample environment is there is code in our startup program to look from wherever the running program is, and it looks up through the directory levels until it finds a folder called whatever it is defined here, sample data in this case. And then it will then look through all the files it knows about, and it will define logical names. So that in the repository we had dat:/customer.ism. So it will define dat: to that sample data folder. And that sample data folder has those sequential and XDL files, and as the server starts up, it has code to create those files and load the data. And when the server shuts down, the ISAM files are deleted again. So that's not appropriate for your actual environment, but in terms of developing and testing, it's quite convenient to have a fresh set of data all the time. And that is a conditional option. There's a thing in the code generation file that enables that. So it's not turned on by default, so we're not going to start wiping out your data unless you tell us to. Okay. So this file is just values that we can edit. For example, if we want to host on different ports, here's the HTTP port, here's the HTTPS port. There's the base path that we're using. Throughout the week, you've seen samples, and it's always https://port number /odata/something. That's a very common attribute in a RESTful web service, is that there's some path. In web API, it tended to be /API/something. In OData, it tends to be /OData/ and then the path to the resource that we're trying to get to. But if you want to call it something else, you can rename it here. And that's basically what this file does. It's just values that are used. These values are injected into various places when we're generating code. So that's the user-defined tokens file. Let's look at how code generation works. So if you're not familiar with code gen, it's just a command line option. Okay, code gen, and you give it a bunch of command line options and tell it what to do. Okay. If you want to get familiar with code gen, one of the best commands to know about is codegen-docs, which will load up the documentation file that gives you, there is introductory information about what codegen is and how it works and what it does, and the command line options that are available to you and what they all do. And then there's notes in here about preparing your repository and various things you can do in your repository to support code generation. And then it's basically a reference for all the different kind of tokens and expressions that CodeGen supports. I'll give you a brief overview of what it actually does in a few minutes' time. By the way, the CodeGen documentation is available, I think if you go to codegen.synergex.com, documentation, Okay, so codegen.synergex.com/help will always have an HTML version of whatever the current version of CodeGen is. The documentation will always be there at that web address as well, if you're on a machine that doesn't have CodeGen installed, so you don't have access to the help file. Okay, so we've looked at the user-defined tokens file. This is a file called regen.bat, and this is where we're going to put our commands where we're going to generate our code. You'll see that at the top of the file, there are these 3 pieces of information. These are defining the directories where we're going to generate code into. So if you do build up an environment yourself and don't use our suggested project hierarchy, then you might need to customize. We've got a project called services, which is in a subdirectory of where this batch file is. So we're going to generate into that subdirectory. Our self-hosting code is going to go into a folder called services.host. Later in the day, our unit testing code is going to go into a folder called services.test. So if you want to generate the code to some other place on your system, you just need to tweak with these settings. A little further down, you will see we've got this environment variable called data structures. So what we're going to do here is list the structures that we're going to be generating code from. And file structures in our example is going to be the same as data structures. And there's a little description of what these things do here. But the difference basically is, if you have, let's say, an ISAM file that has 3 different record types, okay, what we're going to be doing is generating code from 3 structures, but there's only 1 data file. So because we don't have any of those, data structures and file structures are basically the same thing. But if you had multi-record format files, then file structures, you would only need to name one of the 3 structures that refers to a single file. So file structures may be a subset of data structures, and that's what this text is describing here. We also have this Paramus structure. Again, this is kind of hard-baked into our sample environment. This is where our system parameter information is coming from, our next customer number, and so on. So let's skip through these options for the time being and just show you what happens by default. So here's a CodeGen command. Okay? It says CodeGen -s is the list of data structures, so customer, vendor, order, whatever. Those are the structures we're going to process. -t is the templates that we're going to process. Now, I'm going to show you what a template is in a moment. So what CodeGen does is it takes information from a repository structure. So it takes information about the fields, the data types, the sizes, the prompt, all of that information that's available in the repository, and it merges it with information that's in a template file, okay, in order to produce some kind of output. So let's just take a look at a template file, just to hopefully give you an understanding of what's happening. So also in your sample environment, you have a folder called templates. Okay, so these are all the CodeGen templates for the things that we're going to generate in this environment. Let's look at a fairly simple one. I'm going to look at OData model. So this is a CodeGen template that generates a model class. Okay, I described a model class earlier as representing a record. So a model class has properties that reflect the fields in a record. Okay, so how does CodeGen achieve this? Well, if you look at this template and any of the templates, you will see that they are a combination of actual code and tokens. Okay? The tokens are all delimited by less than, greater than, kind of like XML tokens or HTML tokens. So these tokens do typically one of 2 things. They either get replaced with some piece of information, typically something from the repository, or they give an instruction to the code generator to make something happen. Okay? So for example, this top line here, CodeGen file name, is a way of determining what will be the name of the file that's generated when this template is used. Structure no plural will be replaced with the name of the structure that's being processed, and the no plural bit says if it ends with an S, we'll strip the S off the end. Okay? So customers will result in customer. Okay? You'll notice that some of these tokens are in uppercase. You will see others that are in lowercase. You will see others that are in mixed case, like this one, for example. That is relevant, okay? If this token structure no plural was all in uppercase, then the text that was inserted would all be in uppercase, okay? Because this token starts with a capital and then goes lowercase, and for the next word goes uppercase, then lowercase, the text that's inserted will be camel-cased, based on underscores in the original names in the repository. So if we've got order underscore items, this token will insert order items, okay? Which isn't actually that relevant in Synergy because we're not a case-sensitive language, but in other languages, there's nothing that says you can't generate C# code with this or Java code with this, where clearly case is very relevant, okay? So that's why the tokens work that way. This second token requires code gen version. Actually, that's correct. Should be 536, actually. Anyway, you can guess what that's doing. Telling the code generator, there's something here that needs a feature that was in this version, so make sure you've got at least that version available. Requires option TF. There's a command line option TF. I'm not going to go into the details about what it does now, but that option has to be present on the command line in order to process this template successfully. CodeGen folder models. So wherever we tell it to put the output, we're actually going to put the output in a subdirectory called models. Okay, so these are all instructions to the code generator. These lines are what are called template file comments. So // is a comment in the template file. These comments will not be part of the generated output. They're simply there to document the template file. If we look further down, however, here we've got regular Synergy comments. So this is just text that will be output. So when this template is processed, these comments will be written to the output file until it gets here, and then it'll say, okay, well, I'm going to insert the name of the structure that we're dealing with in the output file, and then we'll carry on. And I'm going to carry on down. Now we've got some if statements in here. So we're saying if defined, enable field security, and there's a matching end token. So you can probably imagine that that's just an if statement saying if some setting is set, then we'll include this line of text. If it's not, we won't. And all the code generator does is work down this, well, it's not quite as simple as that. It's a whole tree processing thing. But essentially, what it does is just work down this template, following instructions and inserting information as it goes in order to produce a piece of output code. Okay? So if we look further down, we'll see we've got a namespace being inserted, public partial class customer, extends data object base. We've got, we're inserting values here. As we go further down, I'm looking for something specific. Okay, here's an important concept. Field loop. Okay, so field loop says, and remember, we're processing this template in conjunction with a repository structure. The repository structure has fields and keys and relationships and all that kind of stuff. So this says, from the beginning of the field loop through the end of the field loop, whatever you find between, repeat that piece of template code for every field in the structure. Okay? For even further, it says, so now we're doing it for every field. We're saying, if required, is this a required field? In which case we'll insert this. Is this an alpha field? We'll insert this. Is it a date field? We'll do something special. Is it a time field? So we've got a combination of if tests, insertion of values, and real code in the template file, and then we get an output file. Does everybody kind of follow that? I know you don't know everything about CodeGen, you won't at the end of today even, but you get what's happening in a basic form? Okay, cool. What I would suggest you do, and you don't have to do this, but I find it extremely useful, on my menu in Visual Studio, you'll notice I have a Tools, Generate Code, and I've actually gone one step further and assigned a shortcut key to it. So I'd suggest we all do that, and the way you would do that is in the Tools menu, go to, there's an option called External Tools, and that should bring up this little dialog. And what you would do is just click the Add button and just reproduce what you're seeing here. Let me see if I can zoom in a little bit. So I would suggest you add an external tool, name it Generate Code. For the command, you want to say $solution dir, close paren, regen.bat. So $solution dir is Visual Studio will tell you where the directory that the solution lives in. And then regen.bat. Put the initial directory to $solution dir. And make sure you check the use output window option so that any output that this tool generates will be placed into the output window in Visual Studio. Okay, everybody got that? All right. So all we've done by doing that is we've given ourselves an easy way of executing that batch file. So now, whenever we go tools generate code, it will just run that batch file and whatever commands are in there. So let's look at what's in the batch file by default, and we're about to generate code and get things up and running. So I realize this early part was a little bit long-winded, but we're about to make some stuff happen. So by default, we have 2 CodeGen commands in our batch file. All of the others down here are all protected by if defined something. So that's what all of these options are up here. So all of the others are turned off. The only 2 that are in play right now are the very first 2 CodeGen commands. But look what's happening. We're saying let's combine data structures. In fact, let's fill out our data structures now. Everybody go back up towards the top, and where it says data structures, let's name our structures, which are customers, space, items, space, orders, space, order, items, space, and vendors. Okay, so those are the 5 structures that represent the 5 entity types that we're going to be dealing with in this environment. Customers, items, orders, order items with an underscore, and vendors. And again, because of our primary key generation, scroll down a little bit, and where it says paramster equals, we're going to name sysparams. S-Y-S-P-A-R-A-M-S. Okay, and just hit Control-S to save those changes. All right, I'm going to scroll back down to those 2 CodeGen commands. So what's going to happen with this first command is CodeGen is going to say, okay, I know about 5 data structures, customers, items, orders, order items, and vendors, and I'm going to combine each of those with 3 templates: OData model, OData metadata, and OData controller. And I'm going to output my files -o to solution services project. And the namespace, -n, specifies a namespace to satisfy the namespace token in a template file will be whatever the services project is. And then we've got this stdopt. stdopt is defined a little bit higher in the batch file, and it's just a bunch of additional options. Where is it? Here. That are being used in this. It's naming the user-defined tokens file. And basically what this is all about is all of these enable authentication, enable field security, enable property. None of those things are there right now because they're all commented out. But basically, as we enable options in this batch file, we're just adding things to the CodeGen command line and then detecting the presence of those options in our templates and causing it to generate different code. Okay? So this first CodeGen command is going to create 15 source files. Okay? It's going to create, because there's 5 structures, so it's going to create 5 model classes, 5 metadata classes, and 5 OData controller classes. Okay? The second command is a little bit different. What this one is going to do is take our 5 structures. Okay? This -ms says we're going to run CodeGen in multi-structure mode. So in this mode, it combines every structure with every template, and we get 15 output files. In this mode, it combines all 5 structures at the same time with each template. Okay, so all of the structures are available to us within a single source file. So this is going to create our DB context class, our EDM builder, and our startup code. So basically, we're about to generate all those initial classes that we kind of walked through in the books sample earlier. We're going to generate our own versions of those with our data. Okay. Now, at this point, we may run into an issue, or we may not. Let's give it a shot. What I would like you to do is open up a source file. Doesn't matter where. In the services project, maybe open up any of them, the startup.dbl. Actually, we're about to overwrite this file, but that's okay. Just make sure you've got a DBL source file open. That may help us. Occasionally, the first time we do this, we find that CodeGen can't find the repository. So let's see what happens. Let's try all together, tools, generate code. What you should find, well, mine worked, so hopefully yours did. You should see something happening in the output folder. And are you all seeing something like this? Okay, good. Occasionally, the RPS mfill and tfill environment variables aren't in play right now, and you get a whole bunch of can't find structures. But assuming you're seeing file names like this. So this is CodeGen. Here's our two CodeGen commands. There's the first one, and there's the 15 files that were generated. There's the second one, and there's our DB context, EDM builder, and startup. Okay? So our next task is to get that code into our project. Okay? So we're going to go work out, most of this stuff goes in the services project. So what I would like you all to do is highlight the services project, right click and say add existing item. Okay, and it should default to the correct folder, so you should be in Harmony Core Workshop Services. And some of these files are already in the project and some aren't, but just go ahead and single click on the top source file there and then shift click on the bottom source file, okay, and hit the add button. And you'll see we added a couple of extra source files into the project. Okay, we need to do the exact same thing on the controllers folder because we just generated 5 OData controllers. So let's right click on controllers and say add existing item. Now you'll have to drill into the controllers folder, and again, just select all 5 of those, so click and shift click or Control A to select all, and press the add button. And we need to do the same thing on the models folder. So right click, add existing item. This time you'll have to go back up to services and down into models and select all 10 of those source files and add them into the project. Let's take a look at what we just created. Okay, so we generated a whole bunch of stuff. Let's look at a data model. So again, follow along if you wish, or just follow me on the screen. So the first type of thing we just created was our models, our classes that describe our records. Okay, so if we scroll down a little bit here, you'll see that we're in a namespace of services.models, which matches the project hierarchy here. Again, that's what we'd recommend you do. And you'll see that we've got a public partial class customer extends data object base. So it inherits some basic functionality from the environment. You'll see that the class holds 2 instances of the Synergy record that's being represented. So it holds essentially the current copy of the data and a copy of the data in its original form so that changes can be detected. You'll also notice that the model holds a reference of a metadata class, or an instance of a metadata class. The metadata class describes the hierarchy of the model in more detail to the entity framework provider. We'll look at the metadata class in a moment. There are a couple of constructors that allow a new entity to be created or a new entity to be created where a record is passed in to populate the data. And then we have basically attributes. So the attributes are the properties that represent the fields. Okay, this is the result of that field loop that we saw in the template code a few minutes ago. So for every field in the record, we have a public property customer number, public property name. You'll notice we're using .NET CLS types, not Synergy types, because we're exposing this to non-Synergy environments. So we're transposing our alphas and decimals. mSynergyData.customer number is a D6, as you can see as we hover over it, but we're exposing that as an int, and so on. Okay, so within the model class, we're dealing with Synergy data. Outside of the model class, we're dealing with .NET CLS compliant data. Okay, and as you can see, each of these just has a getter and a setter that accepts the data and returns the data and formats the data in some cases as necessary. And that's pretty much what a model class does. Okay, the bulk of it is just those properties. Okay. So the metadata classes, so alongside each model class, there is a metadata class. And the metadata class, its job is to describe the model in more detail to the entity framework. So the kind of things we see in the metadata are, we've got a reference to the original structure name in the repository, we've got the size of the structure available in the metadata, and we've got a description of each field that's available. So it's describing to the entity framework that the customer number, which is now represented as an int, actually under the hood is a Synergy decimal, its length is 6, this is its position in the record, I think that's its precision if it's an implied decimal, and so on. I forget what the last one is. Yeah. And in some cases, I think I mentioned yesterday, we have this little code that you can embed that says, if this is a numeric field but it has a format string, I want to expose the formatted string. We've done that on our phone number and fax fields here. So that's why we've got these Synergy decimal converter literal formatters that enable the data to be converted to and from the format that we're exposing it as. Also, what we've got here is key information. So we're declaring to the entity framework provider any properties, fields, that are involved with any key segment in the structure. We're declaring those things so the entity framework knows which of the properties are key segments. We're not declaring which key they're part of, and they may be part of multiple keys, but all of these fields are involved in key segments. And that's basically the primary job of the metadata class. Okay, what else did we generate? We generated an EDM builder, an entity data model builder. Let's go and look at the code. So we'll find that in edmbuilder.dbl. So the EDM builder class is responsible for building an entity data model. An entity data model, as I mentioned earlier, essentially describes the metadata of the environment, the schema, essentially. It describes the database schema. So it declares what tables are out there and what relationships are present and things like that. So as we look in the EDM builder, if we scroll down, we'll find that we're declaring in the getEDMModel method, we're declaring that we have entity sets of customers, items, orders, order items, and vendors. Okay? We're also declaring any entities that have a single segment primary key. The key is described to the entity framework directly via the model class. So if we look back at customer, for example, what we will find is that on the customer number property, there is an attribute, key. So this is telling the entity framework that this is the key for this entity set. In the case of multi-segment keys, the mechanism is slightly different. So order item, for example, has a two-segment key, order number and item number. So for multi-segment keys, the EDM model has to declare that order items has key, order item, order number, and order item, item number. So that's essentially declaring multi-segment keys. Also, the EDM model builder, this is declaring all the keys that are available. Okay, so we're declaring all the alternate keys, essentially. The fact that customer has a key on state, a key on zip code, a key on permanent payment terms. So that's declaring all the alternate keys to the environment. And later, as we go through and add more options, additional things will get exposed through the entity data model. For example, relations to other structures will wind up getting declared in here as well. But for now, essentially, we're just declaring the entity types and the keys. We don't have relations turned on right now. Then we have a DB context class. The DB context is a service that's available in the environment and exposes the actual data at runtime. Okay? So the DB context class, its primary function is to simply have public properties that expose each of those entities. So we expose a DB set of customer, a DB set of item as public read-write properties. Okay? So these are the properties that our controllers are going to access in order to access the underlying data. If we want to refer to all items, we just refer to dbcontext.items, and the EF provider provides that data. If we want to drill into a single item, we refer to dbcontext.items, and we pass a key value, or we call .find or .find query, or those extension methods that drill into the data and filter it based on your requirements. Okay, and that's the primary role of the DB set or the DB context. It just exposes the data. Controller classes. So the controller classes are our actual web services, right? So a web service is a series of controllers and each controller exposes operations that are associated with URLs that we can call into. So here's our customers controller. We'll review this code, and I'm aware it's 10:30, so we'll take a break in just a moment. So here's an example of one of our controllers. Public partial class customers controller extends OData controller. So a lot of the basic functionality is being provided by the OData environment. We just declare our endpoints. Here we have a constructor. A constructor is our opportunity to use dependency injection to say, I would like to use an instance of the DB context, please. And that's what's happening here. Okay? So we don't have to have this constructor here. It's totally optional, but we're using it so that we can declare a parameter of type services.dbContext, and it is the environment's job to provide an instance of that thing for us. That's what's called dependency injection. So we simply declare through a parameter, we want one of these, and the dependency injection container provides it to us to use. So we are going to take that DB context. You'll see we've got a public read-write property up here, and we simply save it away in that property. So throughout any operations in this class, we've got the DB context available. It was handed to us when an instance of this controller was made. And all else we have in here is our endpoints. Okay? So this particular controller in its current state has two operations, or two endpoints that are available. We have one that, these endpoints are defined by these OData route attributes. So remember, our service has a base address, HTTPS localhost 8086/OData, as defined by our settings file earlier, and then we add /customers is the address of this operation. And by the way, the names are very relevant. The fact that this method starts with the word get is a convention. This is the convention over configuration thing. So the fact that the method starts with get says an HTTP get is used to address this operation. So if someone does a get to /OData/customers, this is the code that runs. Okay? Simple as that. All it does is mreturn OK of. OK is a little helper method that is surfaced by OData controller. And all it does is it returns a 200 OK response, and we get the opportunity to embed data within the response. We're doing HTTP stuff here, but you're not going to see any HTTP. You're just going to implement methods and call code. Okay? But this is called by an HTTP GET request to this URL, and this generates an HTTP response, which is a 200 OK and contains all customers. Okay? The framework steps in, takes all that data, serializes it all to JSON, builds the HTTP response, and sends it out to the consumer. That's it. We're not going to see any of the HTTP stuff actually happening. Okay? The second example is a little more complex. This is, actually we've documented it this way. We typically don't use it this way. This is customers /1 as a URL, okay? You can, if you wish, also say the primary key field name. With alternate keys, it's a requirement that you specify segment name equals value. With the primary key, you can if you want, you don't have to, okay? So this could also be represented like that, customer's customer number. And you'll notice there's a curly braces around the a customer number, and that value matches the name of the parameter here, which is also attributed, by the way, as from OData URI. So it's basically saying the value of this parameter comes from the URI in this position. Okay? So if anybody calls with a get OData customers number, close paren, this is the code that runs. And all it's doing, it's returning a single result of customer. That's just a helper method that, again, constructs an HTTP response containing a single entity this time. And the entity is DB context customers find query returning customer based on the parameter a customer number. So that's using the EF provider to say, go get this customer from the collection of customers for me. Okay? There's our basic operation. And we've got the exact same thing, just with different data in items, orders, and vendors. So now we should have 10 endpoints on our service. It's 10:30. Let's take a break, okay? We'll take a 15-minute break.